Good afternoon, good morning, good evening. Welcome to everybody, wherever you are. We've got something approaching 400 people tuning in to our webinar this afternoon, the PETinar, hosted by PETplanet Insider and presented by Husky in the person of Michael White. Michael is the business manager for closures at Husky Injection Molding Systems. He's responsible for the market introduction of new beverage closure injection molding technologies and Husky's portfolio of closures globally. And he has a professional background in marketing and product management and held various product manager and product marketing positions over the past 20 years at Husky's Vermont, USA, and Bolton, Canada campuses. So he knows what he's talking about. He's the man to have on this occasion. Now, Tethered closures is the subject this afternoon, and it's a topic that is rising up the agenda. It's becoming law in the European Union quite soon, and with some of these things where Europe leads, the rest of the world is likely to follow. Michael will outline the legislation, the requirements, and the opportunities. Now, we will have an opportunity for questions at the end of the presentation, which will take about 35-40 minutes. Plenty of time. Please keep your questions relevant to the topic. Don't necessarily say hello to your pals in other parts of the world because they won't get through our moderation. We'll pick out the interesting ones, the most interesting ones. Feel free to ask whatever you like. I look forward to hearing from you, and I especially look forward to hearing from Michael. Over to you, Michael.
Thank you, Rory. Hello, everyone, wherever you are. So I just want to begin the discussion by talking a bit about an intro to Husky. So who is Husky? A leading supplier of injection molding equipment to the plastics industry. We operate in a number of key markets with turnkey manufacturing solutions. And when I say manufacturing solutions, I'm referring to the entire work cell. So the injection mold, the injection molding machine, the upstream, downstream auxiliaries. We provide a total manufacturing solution for the PET packaging market, the specialty closure market, the beverage closure market, and also high-end tooling for the medical market. We also have complementary to that. We have an extensive hot runner and control portfolio that supplies not only those key markets here that I've mentioned, but also things like the automotive industry, the telecommunications, different areas there. Now, if we look at our global presence, we have manufacturing locations in Toronto, we have manufacturing location in Luxembourg, Shanghai in China, and also a mold operation in both the Czech Republic and California. Supporting that, we also have a number of sales and service locations located globally. That entire installed base is supported by close to 500 strong customer support network. Our team members are just about evenly split between Asia Pacific, Europe, and the Americas. And just an interesting tidbit, every second, our equipment or our system, our manufacturing solutions are outputting approximately 15,000 preforms per second. And on the closure side, about 1,000 closures per second. With that introduction, I want to switch gears a bit now and give a bit of background on tethered closures. So the European Parliament passed legislation back in March of last year of a single-use plastic strategy. So this covers a number of different areas, everything from plastic cutlery to straws, fishing lines, stir sticks, increased use of PCR material in containers, and of which one of those subsegments is the tethered closure topic. And that's what you're all here to listen to today and discuss. But the key item that's coming out of that is any brand owner that wants to sell into the European Union by July of 2024 that has a a single-use plastic beverage container of a volume of 3 liters or less needs to have their closure tethered to the container. Otherwise, they are not allowed to sell into the European Union. And we really think that this is the first domino to fall. There has been previous legislation in the United States that has been proposed in the legislatures of the state of Maine, the state of California, for tethering, but for whatever reason, those proposals or those bill proposals never made it into law. But what we see now is we think with this European Union directive, this is really the energy that's going to be needed to start to have the dominoes fall in other global territories. And I think that you're going to start to see things like the California law be re-energized in some form or another. Here in Canada, there's legislation that's being considered, currently deciding what type of criteria is going to be defined. I know in Australia, they're looking at single-use plastic legislation as well. So this really is not a question of if, but I think a matter of when more single-use plastic legislation will be mandated across the globe, and also the tethered closures as well being implemented in other jurisdictions. And we really think that that's a good thing, right? You know, from a sustainability perspective. And as I'll get into, these are things that can help to enhance your brand as a brand owner. Some other indicators that I see when we're speaking with resin suppliers, or we're receiving brand owner inquiries, they're not just coming from Europe, they're coming from all over the globe. You know, the resin suppliers that don't sell into Europe are looking to evaluate different resin and master batch combinations with our tethered designs. So again, I think it's an opportunity, one, to differentiate your brand, and it's an opportunity that should be embraced from a sustainability perspective. So I may have covered part of this already. Why is this legislation being passed in Europe? Well, when they were looking at drafting this legislation, they were doing a lot of investigation, obviously, in their member states and on the beaches and so on. The top 10 single-use plastic items that are indicated here on the right-hand side, everything from cotton buds, so you like your Q-tip, plastic Q-tip type Q-tips, to cutlery, balloon stir sticks, food containers, etc., accounted for more than 43% of all marine litter on European beaches. So that's like at an aggregate level. So again, we see this as an opportunity, as definitely from the tethered closure side. So this comes down to, okay, let's define what the criteria is, or what is the tethering, what are the performance criteria. And really there's a number of different bodies that are involved in this, starting with the SETI organization, where the committee and the organization that's responsible for establishing thread standards for the PET industry. There are a lot of different players within the industry that have vested interest, of which Husky is a member, that are putting together. There's a steering committee that has been formed within SETI, where they are putting together the details for what they believe the criteria should be. From there, it's a bit of an iterative process. Then we're involving the national standardization bodies for the different member nations of Europe, so DIN in Germany, UNE in Spain, Swedish Standards Institute, AFNOR in France. So they're working to make sure that they have their say and their needs are met as well within that body. And then from there, we're then involving the European Committee for Standardization that oversees all areas of standardization within the European Union. And then once everybody can agree on a common standard there, that is then presented to the European Union as the recommendation. Within all of that, if we look at really trying to boil it down on the PET threaded neck finish, what we're looking at here is an opening and closing requirement of at least 15. So 15 openings, 15 closings before any potential failure would occur. And then having the tether, and when I say the tether, I'm referring to the segment here that's connecting the shell to the tamper evident band, of a minimum of 25 newtons of separation or pull force. And that's really where the guidelines are standard existing now, and that's really where any of the options that are being proposed in the market today by Husky and our other industry players are meeting as a minimum requirement. So I mentioned a bit earlier, do we see it as a challenge or an opportunity? Definitely it's an opportunity, and for the following reasons. One, it's promoting as a brand the sustainability message. The fact that the closure is tied to the bottle, it can't be easily discarded because of those force requirements that I mentioned earlier. It's an opportunity, depending upon the tethering solution that you use, to actually enhance your brand and use it as a way to position your brand as a differentiator in the market. And then anytime you can tell something new or have something new to talk about to your brand, as far as a storytelling opportunity, something that's new and improved is a good thing to keep your brand top of mind in the minds of the consumer. So when we set out on this whole tethered initiative, we really wanted to understand the needs from the consumer point of view. And we said, okay, where is the consumer when they grab a package at first sight or they see it on the store shelf? What are all of these different moments where the consumer interacts with the product? And how can we enhance that and incorporate those consumer moments into our design? We need to look at, okay, how does it look on the shelf? Obviously, you want to introduce something that won't detract from the brand image that the brand has worked hard to create. The opening experience, obviously, that's something that you don't want to detract from. How is the tethered secured, if at all? And by securing is locking the shell into position so that it's not flopping around. How is the drinking or the pouring experience? Again, by being able to lock the shell in place, that's able to ensure that the drinking or pouring experience is not compromised in any way. And then when you go to reclose the package, is there anything there that with a tethering system that could take away from the user experience? And then reopening again, and so on and so on. You could go through this to 15 times as far as the guideline goes. And then finally, the end of life experience on when that package has served its purpose and it's ready to be recycled. So these were all the elements that we looked at before we set out on our whole tethering development. And I can't stress enough the importance of getting this design right. If you have anything that can detract from that experience, that's something that's really going to impact your brand in terms of consumer appeal. It could eventually result in potentially market share erosion. If someone else, a competitor of yours, has a better tethering system that actually enhances the brand versus detracting from the brand. And I think this resonates with the brand owners. I have a quote here from Philippine Spring Waters, was one of our first customers for our premium tether solution. They recognize the importance of the consumer experience as a critical design input, and that initiative, or the success of the whole tethering initiative, is predicated on delivering an optimal consumer experience. And so again, this was one of our first tethering customers. I want to add that you'll notice the location of this customer is based in the Philippines. So outside of the European Union, legislation. So they recognized it as an opportunity to send a sustainability message and differentiate their product on the store shelves versus all of their competitive alternatives. So I want to, with that in mind, and the importance of the whole getting that design right, I want to show some examples of historical products that have been launched that maybe are less than optimal from an intuitive point of view. This here is an example of a elevator button control. When you look at it, you say, okay, which button is up? Is this one lit? Am I going up? Am I going down? Vice versa. If I draw your attention to the middle example, this was a BlackBerry competitor. Looks very similar to a BlackBerry, but you'll notice the keyboard. Normally, most keyboards have the QWERTY arrangement of letters. This company decided to arrange their letters in an alphabetical format. So you can imagine the frustration for a user that, you know, very sleek, I won't argue with that, a very sleek looking product, but maybe the intent of that alphabetically arranged key pattern, it was maybe not the best use of that, or definitely detracted from the brand equity that this company had. And then finally, I want to point out that the aluminum can industry had a bit of a challenge back in the 70s with disposable pop tops. And here's an example of an old design where you would actually pull away on the pop top to access the beverage. And then this piece here, the seal plus the pull ring can get discarded easily if it's, or become litter if it's not disposed of properly. Some examples of very intuitive design, turning our attention, is the Heinz tomato ketchup with the inverted design that was introduced back in 2002. The following year, compared to their peers in the industry, their sales rose 6% versus 2% for their competitors, and they attributed that primarily due to the ease of use. So you're no longer smacking the bottom of the bottle to get the ketchup out because it's already, gravity has done all the work for you. It's ready to go when you're ready for dosing your ketchup on whatever food you may want. The middle example is the Nest thermostat, the smart thermostat. It has that spinning, clicking wheel. It's got that tactile feedback, the clicking noise, the audible cue to alert you that you're adjusting temperature, in addition to the visual aspect there. So that's something as well that is a very progressive, intuitive design that actually, with the enhancements internally that you don't even see, is the whole learning capability of the Nest. And then finally, probably couldn't go through highlighting intuitive design without mentioning an Apple product. If we think back to 13 years ago in 2007, when the original iPhone was launched, all of the smartphones of the day had a physical keyboard. Apple really introduced the world to the whole pinch and zoom gestures to navigate through their device, in addition to packing in a web browser and a music audio player as well into their device. So these are examples here of some very intuitive design examples that we look to as well for inspiration in our designs. So some of the design considerations, in addition to the consumer aspect from the pouring, the intuitive operation, because definitely you don't want to detract from that, otherwise it'll frustrate your customer. You want to look at things like weight neutrality. You don't want to introduce a new closure design that is an additional or a weight adder on something that's more of a sustainable initiative. Definitely, you don't want to sacrifice performance. So by performance, I'm referring to levels of carbonation retention, opening torques, different things like that. You want to make sure that you're not sacrificing that. And then for existing customers that are looking, or existing tooling customers that are looking to convert over to a tethering solution, you want to minimize the invest, so the number of change parts that are required to actually move over to convert to a tethered solution. And then as well, giving consideration to the whole downstream aspect in terms of minimizing change parts on the downstream filling and capping lines as well. Before we get into the specific designs, I just wanted to draw everyone's attention to the different primary methods on tamper band formation. And essentially, we look here, broken out the closure into 3 distinct areas. You have your shell here, and then you see these little segments that are connecting the shell to the tamper evident band. Those are the bridges. We refer to those as the bridges. And the purpose of the bridges really is to, as you start to unscrew the closure for the first time, those bridges will start to stretch, and eventually they'll fracture. Once they fracture or they turn white prior to fracturing, they're indicating to the consumer that, hey, this product has been tampered with. You don't want this product. So this is something obviously that we need in the design of the closure, and there's different methods on how you can actually create them. So I just want to highlight the 2 primary methods. The first is the molded bridge approach, and we're looking here again at injection molding. So this here, I'll describe, it's a bit of an animation, but I'll describe it first. First here we have our, from here, let's follow my mouse, is our hot half side of the mold. So this is where the hot runner is. The injection nozzle from the machine goes through the hot runner, comes into the hot runner nozzle through the manifold, and then injects into the cavity. So then here we have the core. This really forms the inside shape of the closure itself. The cavity here forms the outer shape, and then the slides, which are these 2 items here on that have obviously this is a section cut, but 360-degree coverage of the cavity itself, and these actually form the tamper evident band and the bridges. So this is again one way of doing it. So what we'll show, I'll start the animation. You'll see the nozzle quickly inject into the cavity, and then the core half moves to the left. So as it moves back, so it injects, pulls back, the stripper sleeve moves forward to separate those slides and then eject the closure off the core itself. Then it retracts, goes through again. So the beauty of this approach is that the closure is ready for the capping line the second it is ejected off the core of the mold. There's no additional efforts that are required or operations to actually form the tamper evident band. The next approach, which is a very valid approach as well, is the slit bridge approach. And there, in the case of injection molding, you would inject the part, but that void would not exist. So there would not be a bridge. It would just be a single piece from the shell down to the tamper evident band. In the secondary operation, the closure is put on a mandrel and it's spun at a high rate of speed along a heated knife. And then you can see here the serrations in the knife form the voids, and then the little gaps here form the actual bridges. So there's 2 approaches to achieve the tamper evident band formation. With that in mind, that'll help us as we start to go through the different designs. So if we were to look at the 2 primary neck types that are used for beverage closures, you have the threaded type and also the snap. Both very effective for the purposes that they're designed for. With the threaded design, you're compatible with all beverage types. So this is your still waters, your juices, aseptic, hot fill, your carbonated soft drinks. With the snap cap, it's more focused on still type beverages like your still water, but it does have the advantage of on-the-go consumption, single-handed operation, so it's quite easy to use. For the purposes of this discussion, I'm going to focus on the threaded type for the rest of the discussion. So when we looked at developing our closure solutions or tethered solutions, there was a number of different concepts, obviously, that we go through in terms of iterations and what have you. We basically pulled it into two primary camps. We have our basic compliance, and then with all of the consumer inputs that I spoke of earlier and the importance of enhancing the brand image, we came up with a premium tether design. So let's focus on the basic compliance or the standard tether approach. Again, here there's various different treatments on how you can actually create the tether. Again, they compatible with all industry standard neck finishes. Also, they can be accommodated to a custom type neck finish, compatible with still and sparkling beverages, and it can be achieved both with a molded bridge or a slit type bridge approach. Just various options. As you can see, it's fully compliant with the 15 openings and closings and the 25 Newton pull force. This here is an example of what we're using as our standard tether. You can see here is the closure untorques. You have that segment that's connecting the shell to the tamper evident band. So as the bridges break, the only thing that doesn't break is the segment connecting both the shell to the tamper evident band. So then what we realized when we started looking at all of those consumer interactions and how do we enhance the brand is it would be great if we could take the versatility of the threaded neck, we can combine it with the ability to fix the shell and lock the shell into position. And that really led us to the development of the premium tether. And that's the ability to have a threaded tethered closure that when you take off, you can actually lock the shell in place. And why is that shell locking so important? I'll get into that in a minute. So again, on the premium side, obviously there was a number of different iterations using our simulation software, touch and feel samples, prototype samples that were made. But the end goal was obviously to be compliant with the regulations, be able to satisfy all of the industry standard neck finishes, and also have that ability to lock the shell in place. And that really brings us to why is it so important to lock the shell in place? Well, the first thing, if you think about it, when you go to unscrew the closure, as shown here, and lock the shell in place, what that enables you to do is you don't have this closure flopping around and where it's the potential to hit you in the face, hit you in the nose when you're taking a drink, if you're going to pour it, if it's just loose and not tethered in place, it could potentially get into the direction of the melt stream, causing spillage. So there's some advantages of being able to lock that shell into place. Also, what was key to us is it's got to be intuitive. You need to be able to open that in a very easy way, flip it over without having to teach everyone or put in special instructions on the label of the beverage on how to use it. And two of the key things that we looked for as well is the ability to have cues. So the user or the consumer for the first time would know that, okay, this is how you use it, both from a tactile point of view and also from an audible point of view. And by doing that, the consumer is aware that, okay, I've locked it in place now, I've felt that lock, and I've also heard that click. And again, from a brand positioning point of view, we really feel that having a feature like this where you can lock the shell in place really extends is an extension of the premium brand approach. So I want to show you two examples here of with and without that integrated hinge. So one example here, you can see I'm just going to pause it, is a non-locking type approach. So similar to the standard tether that I showed earlier. So really what you're relying on here in this type of situation, if you can't achieve that locking, is either manipulating the closure and flipping it around and somehow hinging it on a feature like the support ledge, or creating a plastic deformation. So pushing this to the point where the material isn't going to want to return to its original position, so it's out of the way. Why is that important? If you don't deform it with out of the way, when you go to take a drink again, it's in hitting your face or potentially scraping your cheek. It's interfering with the melt stream, and that's really where we think that we feel that the premium tethered approach offers a better advantage from a usability and user experience point of view. So we'll go over now to the premium tether. Same approach, you unscrew it like you normally would. And just want to back up here for a second. You see that there's this hook or this horizontal tab, small tab that's protruding. How this works is as you go to snap down, this interfaces with this flap here on the tamper evident band, which actually compresses against the neck finish. Also, you have these arms that are then in tension. So combined, this is what helps to achieve that locking position at a very fundamental level. So simply unscrew, pass it over, clicks down, locks into place, flip it back, and you can screw it back on. So one of the reasons why I talked a bit earlier on the molded in bridge is because of those features that we've created to be able to lock the shell in place. There are some more complex geometry, and being able to mold that feature correctly lends itself to the molded in bridge approach slightly better than a slit type approach, because here you can imagine you have the slides that where all of this geometry in both the slides and the cavity can be created quite easily. And then with the slit approach, it's difficult to create these kind of angles perpendicular to the plane of the tamper evident band, different features like this. So we really feel that the molded in bridge approach is the best approach to create this whole premium tether feature that we've developed. So when we look at the different aspects of the neck finishes, there are inherent constraints within each of the neck finishes themselves. So again, there isn't a one size fits all. While you can apply that tethering approach with the arms, the hook, and the vertical flap on the tamper evident band, depending upon the features on the neck finish themselves, lend themselves or introduce additional constraints. So you need to get creative on how we create the locking capability. So an example here is our 1881 with a support ledge of 31 millimeters or less. So here, this behaves very similar to what I've showed you previously on the 2925. It's only when you start to get into other neck finishes where, say, the support ledge is slightly larger. And here's an example as described. So there's this here, we're looking at the exact same neck finish. However, the support ledge is slightly larger at 33 millimeters. If we were to apply the premium tether that I just showed on the previous screen, we wouldn't be able to get that full 180-degree locking position because the tamper evident band would interfere with the shell itself. So what we did is we kind of used the support ledge that was an enemy, now is a friend, by introducing this groove here in the shell itself. We're able to helps to lock the closure in place, along with the same approach that I spoke about earlier with the arms in compression, or sorry, in tension, and the hook and flap in compression. So different slight variations, but to achieve that same end. And this here is just showing them side by side. So the smaller support ledge here, same neck finish, your standard PCO 1881, and then your larger support ledge here at 33 millimeters. Now, we looked at how do we improve this tethering functionality even further. And one of the challenges that we saw on when you have, say, water type application that requires break then leak, and by that I mean the bridges need to break before the plug seal disengages from the neck finish itself, provides a bit of a challenge because you have these extended plug seals on short necks that can create interference when you go to close it back on. Again, our whole goal here is to make it as intuitive as possible to the consumer so that they don't have to think about it. It's just one fluid motion. They're not figuring out, does this locked in place? Do I flip it around? How do I do this? So that's really where we came up here with this integrated cam. And this again is, I think, kind of highlights the level of degree at which we're looking and investigating on how we can improve the usability of the tethering approach to create a seamless consumer experience. Because again, it all comes back to you want to enhance your brand, you don't want to detract from it. So here I'll show you, I have an animation that kind of shows this, how this cam behaves. So again, we're looking here at a standard 2925, standard typical water closure in Europe. Now we have a section. You can see as we go to close, now we pause it here quickly, we have the arrow that's highlighting the collision here with the plug seal and the top sealing surface of the preform. So the user would have to actually, lift it up and stretch it slightly. Now we're looking at the design with the integrated cam. It goes to close. You can see here we make some contact with the top sealing surface, and it perfectly aligns the shell with the neck finish. So again, the goal there is you unscrew it, flip it over, click it into place. When you go to reclose, you push from the bottom of the shell back over, and once the cam makes contact with the top sealing surface on the neck, it's a simply continuing to push that in one fluid motion to align perfectly with the neck finish itself. Again, similar to our non-tethered portfolio, I've been working on a wide portfolio for both the water, the CSD, and also the juices, sport drinks, and teas segment. So again, this isn't complete yet, but we're in the process of expanding and building out that portfolio. You have your snap necks here. You have your standard tether for $29.25, your premium tether, extra tall as an option for weight savings versus the $30.25. But again, these are the industry standard neck finishes that we're talking about here. So all of these, similar to our non-tethered portfolio, are proven designs, have already been validated on lines, and it's ready for, we have samples available ready to run on your production lines. I spoke on the CSD about the two options for 1881, both with the large support ledge, the small support ledge. And then we have two options on the 2622 CSD. This is the GME 3037 neck, not any of the other new developments that are ongoing. This is the current 3037 neck. Again, standard tether and premium tether. So again, the same approach, having it being able to lock in place, and also the non-locking mechanism, depending upon your brand. Maybe you're offering case packs, like here at Costco here in Canada, the 40 case pack, and you're simply looking for compliance because user experience maybe is not the priority with your specific brand. It's more cost driven. That's where a standard tether type approach would be best suited. And then on the juices, sports drinks, and teas, we're a little, I don't want to say behind, but we're starting to build out that portfolio. Again, we wanted to hit where the big push is right now. That's in the water, then CSD, then to the juices, sport drinks. But again, a work in progress in terms of building out that portfolio. So you may be asking, okay, how does this make sense? How does it perform on a line? So we have performed industrial line trials back in July. We ran a 10,000 line with the premium tether without the reclosing feature on a Crohn's filling line. The only change that we need to do to the line, other than some adjustments here and there for heights and different things, is new chucks. And why we need new chucks is to have a chuck design that doesn't have the full engagement that maybe you're used to, that has a partial engagement so that we can accommodate the hook for the premium tether. Again, no issues running it side by side with the non-tethered, performed identical. We have another one coming up in Europe in November. Again, 2925, but this is with the premium tether. Unfortunately, I don't have results to report on at this point, but I don't see any. We don't see any issues with that line trial. And then, in terms of looking at downstream, say handling and different things. So one of the items, the one in the center here, is cap sealing. So some brands out there may have a secondary seal sleeve that's applied to the actual closure itself, in addition to the tamper evident band, etc. So what we've done is we've reached out to Fuji Seal, who's a industry leader in sleeve development and application. They've done numerous testings with their protocols. One of the ones I just want to highlight here is the worst case scenario, where you'd actually have the perforation line coming over top of the actual hook that you see here. And again, reporting back, no issues here on their investigation. And we're continuing to work on palletization. There's different ways on achieving that, either mechanical, vacuum, inflatable. The concern that we had at the beginning is there enough clearance between the hook and the support ledge for the different gripping approaches? And all of the reporting back and findings that we've received so far is that there has been no issue with that. So I just wanted to lend a bit of update on where we stand from a downstream perspective on evaluation. So you may be asking, okay, where do I start? I know that the law is coming, or I anticipate it, or I want to use it as a means to improve my brand on the store shelf and differentiate. A number of things to consider. One, how's your brand and product positioning? Is it a premium type product, or are you looking simply for compliance with the law in Europe? Those are the first things to think about. The next is, okay, what neck finish am I using? Is it an industry standard neck finish where we could use a portfolio type approach where there's an off-the-shelf design already validated? Or am I using a custom neck finish? Or do I take this as an opportunity to convert to a lighter neck weight finish and achieve more resin savings and cost savings? So that's the next thing that to consider. One is your performance criteria. Do we require OEM performance levels of tamper evident band performance, or CO2 retention? So those are things to think about there. Again, what is the weight target? Am I looking to lightweight? Do I have a target in place? What resin and master batch am I using? Different resin and master batch combinations can influence shrinkage rates, so that's something to think about. What is my quality expectation, in terms of gate vestige or stringing or coloration, any kind of cloudy marks? Is there anything there? So those are all the items that you need to consider when looking at implementing a tethered type solution at a high level, without getting into more detail. And simply, if there's any questions there, or you're more confused than you have more questions than answers, give us a call. We have, again, from the first slide I showed, global representation. Can contact me as well, and I'll make sure that we route you to the proper contacts. So in conclusion, I just wanted to summarize some of the values that we see with the premium type approach. One, it offers that true 180-degree locking, which promotes the user experience, a positive user experience, to enhance the brand and the brand image. Features like the reclosing cam to help the intuitiveness of the operation. Make sure that you're not having to teach your customer how to operate your package, your closure and dispensing system. Because if you have to do that, it takes away from the brand. Obviously, we see that the premium type approach is an enhancement for your brand, and we have weight neutrality targets. I do want to say that if we were to implement something like the reclosing feature, it does have a 0.05 gram weight penalty at this point, but we're continually looking for opportunities within the design themselves to take waste out of the design and help to lightweight the package. Full compliance with the European legislation. So what I showed on the previous slide of the portfolio, all of those closures comply with the 15 openings and closings in the 25 Newton pull force. No detraction in terms of performance from our non-tethered variants. So the 1881 non-tethered performs at the same level in terms of, say, carbonation retention as the tethered approach. With the molded in bridge approach, again, you're ready for the capping line straight away. There isn't additional operations that need to be done. And again, I think that it's a great opportunity to embrace the whole sustainability message around tethering, and a way to, if you're outside of Europe, to enhance your brand as an opportunity to promote sustainability and differentiate yourself from the competition. So I encourage you to learn more. There's links I can provide as well if you want to reach out to myself or Rory. With the European SUP legislation, I had that on the initial slide, the homepage that goes through all of the directive details. Feel free to check us out at husky.co, follow us on social media, and we also have a tethered closure design guide that you can refer to if you just take a note there of the URL, campaigns.husky.ca/tethered closures guide. And with that, I want to thank you for the pleasure of your time.
And hello, everybody, again. Sorry about that. Small technical issue, which has been resolved totally. Thank you very much indeed for a very interesting presentation. It told me some things that I didn't already know, including that I'm an expert on European legislation. Probably refer that to PETplanet Insider rather than to myself. I can always find out and come back, but give it to the people who know. Now, there is something that I wanted to ask before we go to external questions. I have that privilege, and that is with the bridge setup. It's a mechanical engineering thing. So how do you manage to combine the bridges, which are designed to break as you undo them, with a tether that can resist breakage force up to 25 Newton meters, which is quite a lot?
Yeah, basically it comes down to the amount of plastic that you incorporate into the connection points. So by beefing it up, you're increasing that resistance for the force. Versus if we look at the cross section too, on one of the animations that I showed with the standard tether, when it
Yeah.
was pulling off, the cross-sectional area of the tether itself is significantly larger than those bridges around the closure.
Okay. Oh, all right. Okay, that's fair enough. Now we've got a few questions already, and I'm going to bring a couple of them together. One of them is from Jos Zert, who I hope I pronounced your name correctly, Jos. He is asking, apart from being tethered, not going into environment, could you also break down the other sustainability aspects? For example, is this cap now better recyclable as well, because it is separated in the PET recycling process instead of in the after-use disposal process? And we've got something very similar from Uwe Muller. Doesn't this tethered closure complicate the recycling process of PET bottles?
I would argue that no, it doesn't. What
Okay.
it does is, one, with the tethering, you're keeping it out of, say, the landfill. One, two, you're keeping it off the beaches, which is another issue. And then there's a lot of recycling streams equipment that is out there today by Arima with the float type approach, where the recycled bottle goes to the municipal location, or that central location is ground up and then goes into a float channel where it's the label, it's the bottle, it's the closure itself, all ground up into this water bath as it moves along a canal. And the PET has a higher density, so it sinks. The HDPE floats along, and then it's separated that way into different streams for recycling, for further operations.
Right, because using different plastics has been a problem with closures in the past. And of course, we reported quite extensively on the cap that Coca-Cola Amatil in Australia is now using, which is all made of one material, HDPE, the sports cap. Now, right, we've got
the technology does exist though for separation.
Fair enough. That's fair enough. Now, what's I've got from I'm sorry. This is me being really cheeky with the way my name is spelled, but Shuvik Mukhopadhyay. I hope, and I sincerely hope I pronounced that correctly. But what changes are required in the existing capping line for a tethered cap, and what will be the ROI and the payback period? I think that's actually a question that an awful lot of people, particularly maybe smaller bottlers, are going to be worried about.
Sure. Now, depending upon the tethering approach that you use, there would be, potentially no changes, like a standard tether where you're all within the shadow of the shell itself. So it's same height. But if we go to something like the premium tether, on one of the slides I showed is the level of engagement between the capping chuck is slightly changed. So it would be requiring new capping chucks. That's what we found on our industrial line trials that we've performed so far. The only changes, and then there's some adjustments here and there of the pickups and heights and different things, and maybe adjustments of the rails, but it's just the capping chucks at this point, and then it depends upon your capping number of capping heads that you're using, but you could have a ROI of a few weeks, month or two. It all depends on how many capping chucks you require and your specific operation. But if we can boil it down to what we're finding now on our developments is either nothing or new capping chucks, worst case scenario.
Okay, so essentially it's tooling. It's not the hot runner. It's not the compression unit. Which yes,
I thought
it's a tooling thing.
And just to clarify, my interpretation was the question was on downstream equipment. So if we're also looking at full scale, what else do I need? There would be changes on the tooling, obviously. So depending again on what type of tethering approach you would use, it could be as little as slides for the standard tether. And then if you wanted to go to something like a premium tether, you would need the outer cores, slides, and cavities. So the investment there obviously is a little higher. You may be looking at 50% of a cold half, but that would be in line with other industry players as well.
All right, now Shuvik has asked the second question. It's fair enough. Is will there be any difference in opening torque between threaded and snap type?
That I think is all dependent upon the. No, I don't think there would be. It with no, no. I can take his information down as well, but
Okay.
I don't think there would be any differences.
Okay. Shuvik, if you could send us a message with your contact details, if we don't already have them, then Michael will be very happy to get in touch with you.
And I could somehow broadcast out to everyone else, anyone else that's interested. Yeah, pile on to that inquiry.
Okay.
I'll make sure that we answer.
All right. Your next question we've already covered, which is the cost aspect. Now, Bernardo Oses asks, what about patents or intellectual protection compared with similar solutions from competitors? I think that this is about essentially about brand distinction,
Sure.
design rights, that sort of thing that sets you apart.
Yeah, no, that's actually a really good question. We've done an extensive due diligence. We feel that our design is very novel and inventive, and we've filed patents on the hinge design, and we do feel that it's unique in the industry based on the due diligence that we've done, third-party investigations as well that we've contracted to avoid any kind of potential bias. But yes, it's a great question. There's a lot of IP in this space, and we definitely have done our homework on putting this together. Things like the tethering system, like the premium tether, and also the closing cam patents filed on that as well.
Okay. And a question about the implications of the cam from Isabella Lamaka, who's asking, would the cam increase the closure weight? And if so, how much? I mean, this is a serious question, but this is one about the material requirement in the caps and closures. We've been driving for lighter weight in order to reduce wastage and to reduce the amount of plastic in the environment. And does this step with the aim of reducing the amount that's going into the environment and going to landfill, would it actually have the effect of requiring more weight to be used in the closure?
Yes, it's a really good question. It does add 0.05 grams, the closing cam, onto the closure itself. Now, we are continually evaluating. We like to, or what we say is eliminate waste. And when we say eliminate waste, is we look at the closure itself and where can we take out weight? And weight in this case, we're referring to as waste. Where can we optimize essentially the weight of the closure? Maybe the top panel we can take out, a few microns, sidewall, etc., without impacting the performance of the closure. And so we're continually, that's an iterative process. So as it stands today, 0.05 gram penalty, but we also have the option without the closing cam as well.
Okay. I mean, 0.05 of a gram is not very much on a single bottle, but when you've got a million, adds up.
For sure. Yeah. Again, this all comes down to how you want to position your design as well within the marketplace.
That's fair. That's fair. Uwe Muller has got a second question. It's a very good one. Are sports caps also available, or are they already covered? Are they already dealt with?
To my knowledge, the sports cap, you can still unscrew it, so you would be breaking the bridges. We have not endeavored or initiated tethering initiatives yet on the sports cap, but definitely in putting in like a standard tether approach, that would be something that we could implement quite quickly. But then if we think about how, I think this really requires a rethink, because by the sports cap, inherently you have a flip top for the certain designs. How do you incorporate an additional tether? There's some rethinking on, okay, again, we would go back to that whole beginning block. How is the consumer using the sports cap? and go through that whole cycle and see how can we optimize that and come up with a novel and inventive solution to solve the consumer problem.
Okay. All right. Yeah. So far, this is a question from me. In your tests and what you've done and where you've launched so far, have these tethered caps been well accepted by consumers, or has there been any pushback?
All of ours have been, again, this is me speaking here. All of that I've been involved with discussions have been very positive. And I keep going back to this anecdote at K-Show last year. So this was, 6 months after the law was made official or communicated. Every discussion that I was involved with at that show was tethered caps, regardless if that brand owner or converter, customer, whoever I was interfacing with, whether they were based in Europe or they were based in Australia, United States, where have you. I think, and again, that's the cue that I'm using to really direct or my thinking that this is going to envelop the globe from a requirement standpoint.
That's fair enough, but K-Show is a trade show rather than a consumer show, and it was about consumer reaction that I was asking. Or have you not been able to measure that as yet?
No, we've done consumer studies. Again, sorry for misinterpreting that. The brands that we've been dealing with as well have been conducting their own consumer studies. Right. And what they've been doing, a lot of the bigger brands in Europe have been industry players in addition to Husky, evaluating the designs and coming down. And we've been selected as one of the finalists for our design, the premium tether. And obviously we're not sure of who the other players are, but we've gone from 30 some odd players down to 4.
All right.
So I think that's positive. That's a positive indication.
Sounds good. Sounds good. Armin Vila is asking, will there also be solutions for PCO 1810 closures?
It's a good question. I'm starting to get asked that more and more. Definitely there will be. It is an older finish, but we understand in certain areas that brands still prefer that finish type, just for the grip zone, what have you. Again, we have a finite budget when we go to it's not unlimited. So when we go to develop, we had to focus on the key ones first, where we see the biggest demand, get those hammered out, and then it's not just a simple copy paste, but we've uncovered a lot of learnings that then it helps us accelerate the learnings for 1810. So long story short, yes, we are looking at it. We just don't have anything commercially available yet. Okay,
that's fair enough. All right. And Shuvik has congratulated me on pronouncing his name correctly, which is gratifying. Now, Vilko Vinstra is, I'm on a roll now. Thank you for your clear presentation. Does the EU directive prescribe any kind of quality assurance in order to comply with the 25 Newton meters requirement on the overall production output? Considering our company's activity, which is manufacturing, sorting, and inspection systems for caps and closures for the beverage industry, do you foresee an increase in two-phase quality control procedures due to this directive?
That's a loaded one.
It's a long one.
What I see is that definitely there will probably be additional testing that's required on the line, maybe not 100%, but you'll do sampling like offline for pull tests, every hour or whatever, just to make sure that it's meeting the standard requirements, the 25 Newtons. And then you'll still have all of the standard quality with no compromise there. What may happen is for downstream inspection, you may have additional cameras that might be required to look at the additional features on the hinge to ensure there isn't flash or things like that.
Yeah. Okay. Jos is asking again about the increase in material. I think you've already answered that. It's 0.5 of a gram per cap.
0.05.
Sorry, 0.05. I do beg your pardon.
Yeah.
0.5 would be a lot. Dominic Murray is asking, how do you guarantee that only the capers have to be changed? I think you mean caps. Was it?
The cappers.
Yeah, cappers. How do the caps get into the right position? And what about guides and camera systems? So technical question there.
Yeah, the one is through the waterfall sorter, using the center of gravity, there may have to be some adjustments made, just so when they tumble, they're positioned the right side for the camera to look at. So that's one, but that doesn't require additional investment. That's just adjustments. From the capping side, adjustments to the rails, different things, because we're not changing the outer diameter of the closure other than that little hook that's protruding out on the premium tether I'm talking. There, all we're adjusting is the level of engagement that the closure fits up into the capping head itself. So again, new capping heads, that's it. The rest is adjustments on the capping line.
Okay. Nevio Simeonato asks, what about the drop of Tamper evidence band? We note that the tethered pilot samples have less evidence than non-tethered caps when reclosed. Is that the case? Is that accurate? Because you were talking about the tamper evident band, the bridges turning white and separating if somebody's been fiddling around with the cap. Are we losing tamper evidence?
No, you still see it. Just maybe in the area where the tether is, like the premium tether, there may be, it may be, cocked just a little bit, that the tamper evident band has a bit of a deformation, but 180 degrees opposite that, you would definitely see the tamper evidence.
Okay. Talking of 180 degrees, Alessandro Delfanti is asking.
Sorry, if I can interrupt just for a sec. If that attendee would be interested, we could send them samples for them to play with and to see, and we could work with them on that. Okay,
Nevio, I hope you got that. If you send your details and your question through, we will pass it on and make sure that Michael gets it. But yeah, talking about 180 degrees, Alessandro Delfanti is asking, with the solution proposed by you, is there an absolute certainty that the cap remains locked when open at 180 degrees? And from the first samples he's seen, this is not always the case.
Yeah, no, he may have received, and so I don't know what samples he received. If I assume they came from Husky, so if he received some samples, maybe they may have been some concept prototypes. They may not have been from a pilot mold that's been proven, because obviously when we're in this development cycle, we're checking for functionality first versus doing all of our performance testing. But we are targeting like a 25 opening and reclosing for locking as well.
Okay.
In addition to the 25 newtons.
Okay. So Michael, what you're saying is you didn't get it absolutely right straight away. You had to do some testing and development.
We didn't.
I'm shocked.
No.
Right. Okay. Dominic Gruber asks, do you see a benefit for the injection molding segment with the tethered caps against the compression molding?
Could be. What we see is that the premium tether with the ability to lock is a distinct advantage. I obviously don't have privy to the different compression competitors and what they're working on. I would never count them out. They're very ingenious when it comes to their developments as well. And there's more than one way to get to Bridgeport, right? So they'll find a different path, perhaps, or come up with a different solution.
Yeah. Okay. Very interesting one from Olivier Baudelaire. Tethered cap is also required for the carton packages market with additional constraints. And has Husky worked on this specific market?
We do, through our specialty business, have like a carton tooling that we have developed. I know at this point, and I'll be perfectly honest, I'm not up to speed on the carton requirements, but I know that that's part of the SETI discussions. And I think, don't quote me on this, but I think they're looking at a still that 15 opening and closings, but I think they're requesting that the pull force is reduced from the 25 newtons down to 12 or 13, somewhere in there. So I think, again, this is a bit of an evolution there, targeting first with the beverage, and then there's, unfortunately, probably won't be one universal standard, depending upon the packaging type and closure type. There may be some different tweaks there.
Okay. Yossut has another question. Are you also going to put a focus on the non-beverage segment in the market?
Do you know what he means by non-beverage? We have a whole division that's focused on specialty closures, and by that is non-beverage. Here we're referring to carton closures, detergent caps,
edible oils,
pouch edible oil. Exactly. There's about 6 key segments that we're focused on. But as I understand, the SUP is beverage only. So I don't think that there's any legislation yet within those 10 segments that target non-beverage.
Okay, but it may only be a matter of time, of course.
Probably, yeah. Probably.
All right. Juliana Malari asks about HDPE grades, and is there any specific property that is important to ensure performance or current HDPE grades, or are they sufficient to give the performance required?
If I understand the question correctly, is just using different HDPE grades for the application?
Yeah, essentially, what are the best ones, and which ones have already been tested? She has a second question, supplementary question there.
Okay, off the top of my head, I mean, we're working with like Dow, Ineos, Sabic, all the big names, Samsung. So in there, we can, again, if she can reach out to me, I can give her the specific grades that we've evaluated. But again, they're all specific to different geographic regions. Okay,
actually, that might be something that we want to let people know about more generally. So if we ask the question offline, and we'll disseminate it through the PET network, PETplanet network. So Dominic Murray is asking about the additional cost impact. I think you've already covered that, really, Dominic.
Yeah.
If you think it hasn't been covered sufficiently, please drop us a line and we'll pass it. We will pass it on. But Laura Gouverneur is asking, how do you see the transition period and any challenges with capacity when the whole of Europe is required to change and comply with the EU directive at the same time? That's kind of an opportunity for you guys, isn't it?
Yeah, it's a great problem to have, right?
Yeah.
I showed one of the beginning slides our global footprint.
Yeah.
So we have tooling and mold making facilities in Luxembourg, the Czech Republic, California, here in Toronto. So we can flex as needed and move around capacity to solve that. We operate in a global economy. We have a very strong global supply chain that has recruited the best-in-class suppliers as well to support. So we're ready for the challenge.
Okay. And a question about palletizing. From Kashif Rashid, we've got, what about the palletizing of the final product and storage if the weight is going to be reduced from the top panel in tethered closures? Well, of course, it's not actually going to be reduced. It's going to be slightly increased. But is there, or would there be any effect regarding cracking or breakage of the top panel or deck of the closure?
Yeah, no, we don't. I used the top panel as an example of taking weight out, but obviously we never compromise performance for weight savings. We want to make sure, obviously, that the closure performs as intended to meet the specific requirements of that brand. Like, for example, if it's a Coke or a Pepsi, they have specific requirements that it needs to reach. We won't compromise on the performance to save a gram, and they wouldn't accept it anyways.
Okay. Yeah, that's fair enough. And I think we have time for one more, which is from Torn Mota. And the question is, how do you see the ongoing SETI developments are going to and can impact the way your solutions work, or are going to impact on the way the solutions work?
I think, well, it's a very, at the beginning, I showed those different segments with the national bodies and so on. It's a very collaborative approach where we're getting input from, not only Husky, but our competitors. We're all working together to this common goal.
Yeah.
So we're working towards that goal. And what my understanding is that the 15 openings and closings, the 25 newtons, there's been countless debates on that where we've come to that conclusion where we're arriving. So I don't foresee, I guess what I'm trying to say, I don't foresee those big numbers starting to move now at this point.
Okay. I mean, something that just
if they were, sorry to cut you off, if they were, we would make those adjustments, but everyone else would be in that same boat.
Absolutely, yeah. But it's really a question of, I mean, 25 openings and closings at really quite a high level of force. Is it an over-engineered solution? Are the regulations actually requiring more than really you think that they need to do? This is a kind of a glass half empty, glass half full question. The engineer will think that the glass has been over-engineered or over-designed.
That's probably a pretty subjective. I think at the end of the day, what we're trying to do, why we have that 25 newtons, or why the SETI committee is, the industry's come to that, is it's a sustainability initiative, and we want to make sure that you want to make sure that the customer isn't, and this isn't a tethered example, but they're not like pulling it off. So you want to have enough resistance there that they're not wrecking that they say, okay, this is probably designed to stay on.
Okay. Right. All right. Well, I think, oh, hang on. We'll just have a quick look. I think, right. Okay. We've got a question from Alessandra Delfanti following up from an earlier one, if you'll take it. According to your initial, and this will have to be the last one, I think. According to your initial indications, is the market more oriented towards the standard tethered versions or towards the premium ones?
What our experience has been when we've shown.
Are you looking at standard or premium?
Yeah, all of our discussions, the consumer, once they see both, or the customer, once they've seen both the brand, they've gravitated towards the premium.
Okay. Oh, right. Okay, that's interesting. And Ricardo, if you send us your details, we will pass your request on. That's it, everybody. Thank you very much indeed. Michael, thank you for a very interesting presentation, and for spending a lot of time on the questions, because we've probably spent longer than I led you to believe. I'm sorry about that. I'm out of crystal balls. But thank you all for your attendance, and we look forward to seeing you again in the not too distant future. Enjoy your lockdown if you're being locked down. Enjoy your freedom if you're not. Bye now.
Thank you, Rory.